Hello again and welcome back to our course on Access 2013 Advanced. In this section we're going to start to look at some of the more advanced aspects of queries in Access 2013, and in particular we're going to look in some detail at SQL, Structured Query Language. Now, I do assume that you've used queries, you're familiar with a lot of the basic to intermediate aspects of using queries, and that you've probably used structured query language itself. SQL is particularly important because if you're aiming to go beyond Access and perhaps to use other database development languages and systems, the common thread in just about all modern database languages and systems is SQL, Structured Query Language. So it's very important to understand that and be comfortable in its use. So before we start to look at some of these more advanced features, let's just have a quick recap on some of the basics. First of all, if you want to create a query in Access 2013, on the Create tab you have two main options. You have the Query Wizard and Query Design. The Query Wizard has some specific options in it. A simple query, and we'll do one of those in a moment without using the Query Wizard. You have the Cross-Tab Query Wizard. I'm going to talk about Cross-Tab queries a little bit later on. I'm going to assume that you're not familiar with those, but I assume that you are familiar with the Find Duplicates query and the Find Unmatched query. Both of those are dealt with in our Basic to Intermediate course. The first one, as the name implies, enables you to find duplicates. So if you think you may have duplicates in one or more tables in a database, you can use this query wizard to help you to find them. And the Find Unmatched will basically look for, if you like, exceptions to what might loosely be called integrity rules. So for example, if you had some kind of relationship that wasn't properly set up and you were trying to find, for example, movies that specified a country where you didn't have the country in the country table, that sort of thing. So apart from the cross-tab query, I'm going to assume that you're familiar with those. On the other hand, if you select Query Design, you get the familiar Query Design grid, and that normally starts with giving you the option of choosing one or more tables to base a query on. Let's do a very straightforward query, and then I want to start talking about the SQL aspects of these queries, and then we're going to look at some specific examples and some of the more advanced queries. Again, we're going to quite often be looking at the SQL aspects in preference. So let's suppose that what I want to do first of all is to just select a list of all of the students. So I'm going to add the students table to begin with, and all I want is a list of all of the students and all the details about all of the students. If I run that query using the Run button on the Design tab of the Query Tools, it gives me a list of basically all of the information about all of the students. Now, one of the options in View is Sql View. And I realize this print is quite small, but I will zoom in on it as necessary. And this typically is a very, very basic select statement. It says select tuple_students.star from tuple_students. You have a select statement which lists the fields to select, and the from specifies the table or tables to select those fields from. The star, as you'll be familiar, means all of the fields. If you leave out the prefix tuple_students. So if I actually delete and just say select star, do you think that will work? Now, if your use of Access so far has been pretty much restricted to the use of the query grid, then you may wonder why you would want to learn SQL. As I pointed out earlier on, one of the main reasons is that SQL is pretty much a universal language, and if you learn how to do queries using SQL in Access, it will stand you in very good stead when you come to use other database systems such as SQL Server. But there are certain things that you can only do by writing SQL statements. There are some things that the query grid is not able to support. Now, to be fair, the vast majority you can do using the grid, but it is very much worth learning SQL. And a reason which is perhaps not so well publicized and understood is this. Although the use of the query grid I think is a really excellent tool, that's a great way of putting queries together, sometimes if you actually look at the SQL, it's easier to understand how a query is working than it is by looking at the grid. And also sometimes if you're trying to put together quite a complex query, I personally find that sometimes writing it in SQL gives me a quicker and more effective result. So let's spend a little bit of time now working in SQL. I've already pointed out that you don't need to put the table name there when the table name is unambiguous. So in this case we're only selecting from one table, so the star there after select can only be all of the fields from the students table. If you want to specify specific fields, then you would write those fields separated by commas, and if say the first field you want is first name, which has got a space in it, you need to put that in square brackets. So there I'm selecting two fields and each of them has a name in square brackets. I generally tend to put field names in square brackets anyway, even if they don't have spaces in them, but let's just run that query. And then go back into Sql View as well. And one important thing to remember is that the standard for SQL statements is that they end in a semicolon. But if you forget to type a semicolon, Access puts that semicolon in for you anyway. Now, one thing that you can do when you run a select statement, as simple as this even, is that you can use aliases. So if I decided that I wanted to do this select, but I wanted to call last name, for instance, family name, I'll make it all one word on this occasion. Watch what happens now when I run that query. In the two columns that I get a field of first name and a field of family name. Now that may be very useful if I want to use this on a form or in a report, and of course I could use this as the basis for building another table. But let's now go back into the SQL. And what I'm going to do now is to use this alias feature, but I'm going to make a completely different field. So what I'm going to do on this occasion is say that I want first name concatenated with a space character, concatenated with last name, and I want to save that as full name. So what I'm actually doing there is taking some of the existing table data that I've got with a select statement, and turning it into a new field altogether with a name of full name. So let's run that query. And now I have a full name field. And that's the basis of the students extended query that's in the student database. But the students extended query is a little bit more clever than that. Now the way in which it's cleverer than that is that it caters for a situation where either the first name or the last name is blank. Now in this particular case all of our students have first names and last names, but in general terms if you were putting together a database, it's probably quite likely that if you were being very thorough about the handling of names, particularly considering the differences in various cultures and locales between the ways that names are handled, you might well need to cater for that kind of situation where one or other of those names is not specified, not known, or not needed. So let's go back into our query now again in Sql View and have another look at how we would deal with that situation. And let's deal with a situation where the first name might be blank. So in order to make this full name we need to build a little bit more intelligence into what we're doing. We're selecting first name and last name, we're putting them together into full name, but the full name will be different depending on what the value of first name is. If first name is null, the full name will only be the last name. So we need to use the if function, the if function. And as you may recall, the if function has three arguments. The first argument is the thing, the entity that we're going to test. The second argument is the value the function returns if the test in the first argument is true. And the third argument is the value the function returns if the first argument is false. So we need an if function, an if function. The three arguments go in those round brackets. The first argument is the thing we're going to test. Now what we're going to test is null. That in turn has one argument in round brackets. And the thing we're going to test is first name in square brackets. Now if the value of that is true, the function needs to return just the last name. So the second argument is last name, of course, in square brackets. And then the third argument will be the expression we built up earlier on, first name ampersand space ampersand last name. So if I cut that and paste it into position as the third argument of the function, that's it. So what I'm saying is if the first name is null, the value of full name is last name. If it's not null, the value of full name is first name ampersand space ampersand last name. Now you can see how complex this is becoming. It's actually not that bad. It can become a lot more complex than this. But you can see how these expressions become more complex, but how this gives you an incredible amount of flexibility in terms of making new fields out of the existing fields in your database tables. So let's try running that one. And as you can see, the full names are coming through fine. Now to be fair, in this particular table we don't have any blank first names. First name is a required field in this table, but then that will lead us very nicely into your next exercise. I've added a fourth field to this query. It's called sort name, and it's the name by which these students would generally be sorted based on last name, comma, first name. If a student doesn't have a first name, then their sort name will just be the last name. So very similar logic to the logic that was used on full name. And what I'd like you to do as your next exercise is to just extend that query that you've just seen. But I want you to implement this in version 10 of the movies database. Now in the movies database, the table you're going to apply this to is the actor table. So all you're going to do is basically produce a list of actors with their full names and their sort names. At least one of the actors doesn't have a first name. So I want you to make sure that everything works okay in the movies database with the actors that have first names and the at least one actor that doesn't. Now if you're feeling really ambitious, you could even take a look at the SQL code for the query students extended in the student database, because you might be quite surprised to find out how complex it becomes when you deal with a situation where either the first name or the last name is blank. The principle is exactly the same, and if you sit down maybe with a cup of coffee and work your way through it, you could probably make sense out of it. But it does become a lot more complex, but the principle is exactly the same. You just need to build these things up in layers basically. So my answer to that is example 11, and I'll see you in the next section.